Welcome to teachers. In this session we will discuss electric current. This is the second video on class 10 physics for the chapter electricity. In the previous video we discussed electric charge, potential difference, voltmeter, etc. Subscribe this channel for getting the latest videos on physics and chemistry of class 10 and 12. Don't forget to click the bell button so that you get notified whenever a new video gets added. So let us now discuss electric current. When two charged bodies at different electric potentials are connected by a metal wire, then electric charges will flow from the body at higher potential to the one at the lower potential till they acquire same potential. So once again, when two charged bodies at different electric potentials are connected by a metal wire, then electric charges will flow from the body at a higher potential to the one at the lower potential till they both acquire the same electric potential. This flow of charges in the metal wire constitutes an electric current. It is the potential difference between the ends of the wire which makes the electric charges or electric current to flow in the wire. We now know that the electric charges whose flow in a metal wire constitute electric current are the negative charges called electrons. Keeping this in mind, we can now define electric current as the electric current is a flow of electric charges called electrons in a conductor such as a metal wire. The magnitude of electric current in a conductor is the amount of electric charge passing through a given point of the conductor in 1 second. If a charge of q coulombs flows through a conductor in time t seconds, then the magnitude I of the electric current flowing through it is given by I is equal to q by t. I is equal to q divided by t. The SI unit of electric current is ampere, which is denoted by the letter E. So the SI unit of electric current is ampere. We can use this formula to obtain the definition of one unit of current called ampere. If we put Q equal to 1 and T equal to 1 second in the above formula, then current I becomes 1 ampere. That means Q is equal to 1 coulomb, T is equal to 1 second, then I becomes 1 ampere. So we can define when 1 coulomb of charge flows through any cross section of a conductor in 1 second, the electric current flowing through it is said to be 1 ampere. That is, 1 coulomb is 1 ampere per second, or 1 coulomb is 1 ampere divided by 1 second. Sometimes, however, a smaller unit of current called milliampere is also used, denoted by ME. Of course, that is not the SI unit, where 1 milliampere is 10 raised to minus 3 ampere. That is 1 by 1000th of an ampere. Thus, the small quantities of current are expressed in the unit of milliampere. The very small quantities of current are expressed in a still smaller unit of current called microampere, where 1 microampere is 1 millionth of an ampere, that is 10 raised to minus 6 ampere. Electric current is measured by an instrument called ammeter. The ammeter is always connected in series with the circuit in which the current is measured. For example, if we want to find out the current flowing through a conductor, such as a resistance wire, then we should connect the ammeter in series with the conductor. Since the entire current passes through an ammeter, therefore an ammeter should have very low resistance. So if you remember from our previous session, the voltmeter, which is to be connected parallel to measure potential difference across the 2 points, should have a large resistance. So once again, an ammeter should have a very low resistance so that it may not change the value of current flowing in the circuit an ammeter is always connected series with the circuit to measure electric current. How to get a continuous flow of electric current? We have just discussed that it is due to the potential difference between 2 points that an electric current flows between them. The simplest way to maintain potential difference between the two ends of a conductor so as to get a continuous flow of current is to connect the conductor between the terminals of a cell or a battery. Due to the chemical reactions going on inside the cell or battery, a potential difference is maintained between its terminals. And this potential difference drives the current in a circuit in which the cell or battery is connected. For example, a single dry cell has a potential difference of 1.5 volts between its two terminals, positive and negative. So when a dry cell is connected to a torch bulb through copper wires, then its potential difference causes the electric current to flow through the copper wires and the bulb, due to which the bulb lights up. In order to maintain the current in the external circuit, the cell has to expend the chemical energy which is stored in it. You should note that a bulb which can be used in a typical circuit is a conductor. We can also call it a resistor as it possesses some resistance. It is clear from this discussion that a common source of potential difference or voltage is a cell or a battery. It can make the current flow in a circuit. Now, direction of electric current. When electricity was invented a long time back, it was known that there are two types of charges, positive and negative. But the electron had not been discovered at that time. So electric current was considered to be flow of positive charges at that time, and the direction of the flow of positive charges was taken to be the direction of electric current. Thus, the conventional direction of electric current is from positive terminal of a cell or battery to the negative terminal through the outer circuit. So in our circuit diagrams, we put the arrow on the connecting wires pointing from the positive terminal of the cell towards the negative terminal of the cell to show the direction of conventional current. The actual flow of electrons which constitute the electric current is, however, from negative terminal to the positive terminal of a cell, which is opposite to the direction of conventional current. How the current flows in a wire? We know that electric current is a flow of electrons in a metallic conductor when a cell or battery is applied across its ends. A metal wire has plenty of free electrons in it. In the previous discussion, free electrons are those electrons which are not bound to the nucleus, so they are free to move. When the metal wire has not been connected to a source of electricity like a cell or battery, then the electrons present in it move at random in all directions between the atoms of the metal wires. When a source of electricity like a cell or battery is connected between the ends of the metal wire, then an electric force acts on the electrons present in the wire. Since the electrons are negatively charged, they start moving from negative end to the positive end of the wire. This flow of electrons constitutes the electric current in the wire. Now let us discuss electric circuits. A cell or battery can make electrons move and the electric current flow. But there must be a conducting path like wires, bulb, etc. between the two terminals of the cell through which electrons can move, causing the electric current to flow. A continuous path consisting of wires and other resistances like electric bulb, etc., and a switch between the two terminals of a cell or a battery along which an electric current flows is called an electric circuit. Symbols for electrical components or circuit symbols will be discussed now. In electrical circuits, we have to show various electrical components such as a cell, a battery, connection wire, wire joints, fixed resistance, variable resistance, ammeter, voltmeter, galvanometer, an open switch, a closed switch, electric bulb or lamp, etc. Now, to draw the electric circuits by making the actual sketches of various electrical components is a very difficult job and takes a lot of time. So, scientists have devised some symbols for electrical components which are easy to draw. They are called electrical symbols or circuit symbols. We will now discuss common electrical symbols for electrical components which are used in drawing circuit diagrams. The symbol for a single cell is like this. The symbol of a single cell consists of two parallel vertical lines, one thin and long and the other thick and short. The longer vertical line represents the positive terminal of the cell, so to be marked as plus, whereas the shorter vertical line represents the negative terminal of the cell, so to be marked with a negative sign. Battery is a combination of two or more cells connected in series. In order to obtain a battery, the negative terminal of the first cell is joined with the positive terminal of the second cell, and so on. The symbol for a battery is the battery shown in the figure consists of two cells which are joined in series. We can also draw the symbol for a battery having more than two cells in a similar way. The connection wires will be drawn with a single line. If there is a joint, there is a wire joint, we will represent like this. One wire is joined with another wire, and this is known as a junction. If a wire is crossing a wire without contact, we can represent it like this. The resistance which can be changed is known as variable resistance, and whose value does not change is known as a fixed resistance. So for a resistor having fixed resistance, the circuit symbol will be like this. And for a variable resistance, it has two symbols. A variable resistance is also known as rheostats. Rheostat is a variable resistance which is usually operated by a sliding contact on a long coil, which is of course made of a resistance wire. So this will be used to represent rheostat. A rheostat is used to change the current in a circuit without changing the voltage source like the cell or battery. It can do so by changing the resistance of the circuit. An ammeter, which is used to measure current, is represented like this. A voltmeter is represented. Ammeter has a sign. V represents voltmeter. And if it is a galvanometer, similarly, we'll put G. The galvanometer is a current detecting instrument which will discuss in the next chapter. The switch or plug key is a device for making or breaking an electric circuit. When the switch is open, then the circuit breaks and no current flows in it. We will represent it like this. So this is an open switch so that the current does not flow. But when the switch is closed, then the circuit is made or complete. This represents a closed switch. Now if it is a plug key, this represents an open plug key, and a closed plug key is represented by a dot inside this, so that something is plugged in so that the circuit is made. Circuit diagrams. The electric circuit consisting of a cell, a bulb, and an open switch can be represented by drawing a circuit diagram like so. This is used to represent bulb. We have a key and a cell. In the circuit diagram, a bulb has been connected to the two terminals of the cell by copper wires through an open switch. The circuit given in this figure is broken due to the gap because of an open switch. So no current flows in this circuit and bulb goes off, or we can say bulb doesn't glow. The electrons cannot flow in this circuit due to the gap produced by the open switch. Let us make this circuit complete by closing the switch. Since there is no gap, therefore the current flows in this circuit and the bulb lights up. In this case, electrons can move through the external circuit. These moving electrons form an electric current. In this circuit, a resistor R has been connected to the two terminals of a cell through a switch, which is a plug key here. An ammeter has been put in series with the resistor R. This is to measure the current in the circuit. A voltmeter has been connected across the ends of the resistor R, that is, voltmeter is connected in parallel with the resistor. This voltmeter is to measure potential difference or voltage across the ends of the resistor R. It is a time to wind up this session. In the next session, we will mainly discuss electrical resistance and resistivity, Ohm's law, its verification, and factors affecting resistance of conductors. If you haven't subscribed yet, subscribe and don't forget to click the bell button so that you get notified whenever a new video is added. So to summarize what we have learned in this lesson, it is a potential difference between the ends of the wire which makes the electric charges or current to flow in the wire. The magnitude of electric current in a conductor is the amount of electric charge passing through a given point of the conductor in 1 second. Electric current is measured by an instrument called ammeter. The conventional direction of electric current is from positive terminal of a cell or battery to the negative terminal through the outer circuit. A continuous conducting path consisting of wires and other resistances like bulb, etc., and a switch between the two terminals of a cell or a battery along which an electric current flows is called an electric circuit.